So you're welcome to our channel of Skills Learning Network for Excellence Knowledge. Now we proceed with the physics practical experiment number 3. If you are not ready for experiment number 1, number 2, subscribe our channel to look those experiments within our channel of Skills Learning Network. Experiment number 3, we are going to deal with determination of electromotive force of a battery and its internal resistance of that battery. In previous, for the experiment number 2, we look about the same aim of experiment, electromotive force of a battery and internal resistance. So which is different? The difference is come from the nature of a graph. So experiment number 3 for today, we proceed with that the aim of experiment or objectives, determination of the electromotive force of a battery and the internal resistance of that battery. We consider the procedure by using the circuit of the experiment. We have electromotive force or battery, we have a switch, we have ammeter, and the internal we have resistance or resistance box. So electromotive force, by using ammeter, we are going to find the electromotive force or E.M.F and the EC, internal resistance. The questions evolving within this experiment number 3, the first one, after performing procedure after recording the results. We are not showing the results because it depends the experiment. We haven't constant data. So after performing the experiment, you can meet with those questions. Question number 1, plot a graph of reciprocal of current against the resistance or R. Another question, calculate the slope of the graph. And another question, what is the physical meaning of the slope? And another questions, you can meet with the use or calculate the value of E.M.F and the internal resistance of a battery. Those are questions which can appear within the question like this one. Then the important thing about this experiment, you have to know the theory of experiment, of the nature of the graph before plotting the graph, in order to get the correct graph, correct baseline, in order to get all marks. It means the experiment, it accumulates or it has a marks for assessment. So in order to get a good graph or all experiment calculations, you have to know the theory evolving to create that experiment. So now we proceed with the theory of experiment. General question for this experiment is E.M.F is equal to current R plus R, and our graph is reciprocal of current against the resistance. So you have to make the 1 over I as the subject from this equation. We proceed with the nature of the graph. In order to get the reciprocal of current, you have to divide the current both sides. Then after that one, this is the question, E.M.F over current is equal to R plus R. We put out of the equation E.M.F in order to get 1 over I. The 1 over I is equal to R plus R. Then in order to remain with the one reciprocal of current, we divide by both electromotive force or E both sides. That is the question after division or dividing. So 1 over I is equal to R over E plus R over E. And then in order to get the R alone to be X axis, 1 over I is Y axis and the R is X. So in order to remain with R at the x-axis, we have to put 1 over E, that is calculations, and the y-intercept is equal to R over E.M.F. And the general linear equation is the same, that is 1 over I is equal to 1 over E times R plus R over E. The linear equation is equal to this one, y is equal to mx. There is a relation, this one and this one. Y is 1 over I, m is equal to 1 over E, R, which is x-axis, and the intercept of y-axis is equal to c, which is R over E. And this represents the nature of a graph. You see, the nature of the graph is going to cut through y positive axis, y positive axis, or y positive intercept. That is the nature of a graph. Do you see? Y-axis is 1 over I, or reciprocal of current. Horizontal axis is equal to R, which is resistance. I think you have C. So M is equal to slope, which is equal to 1 over E from the equation or from the graph, and the C is equal to y-intercept, which is equal to R over E. Therefore the slope is equal to that one, changing reciprocal of current over changing resistance, and the SI unit of slope is equal to reciprocal of V, or reciprocal of volt, and the E.M.F is equal to 1 over slope. So when you want to solve the E.M.F, you have to equate from the slope. So when you get slope, it means the reciprocal of slope is equal to electromotive force, that is the value. So when you get the value, it means you make a substitution. Let's say if you have 3 volt, you say 1, the slope with 3, you can say 1 over 3 is equal to electromotive force. And in order to get the resistance of internal resistance of the battery, you have to consider from y-intercept. Y-intercept is equal to C, which is equal to R over E. That is our solution. R is equal to C times E. That is, you make substitution with the values. To prove the units, in unit to get the R is equal to C times E.M.F, which is equal to C is equal to R over E times E.M.F. It means E.M.F over R times R over E.M.F. It means E.M.F and the E.M.F will be cancelled, will remain with the R. Or you can use this one. Let's check how is calculated. C is equal to 1 over I, which is ampere, times E.M.F, which is I times ohm, and the internal resistance, actually that is resistance. I think you have see how this equation have been derived up to the end to solve E.M.F and the internal resistance. I think you have understood this experiment number 3, and you have learned something which is new to you. Thank you for learning with me. Subscribe our channel, like, share, even give us a good comment about this lesson. Skills Learning Network, Excellence Knowledge is for you. Thank you for learning.